in class. Okay. All right, so solving polynomial equations. We are going to look at how to solve polynomial equations today. It is very closely related to the graphs that we have already looked at, but I'm going to skip ahead a few. Our equations are going to look something like this. There's not going to be a y equals or a f of x equals. It's going to be an equation where you're like solving that equation for x. So, go back to where I was at. The different ways that we are going to look at, and I took this from Ms. Martin's notes, so a couple of these things do not apply to us. Because there are a couple things that we are not going to do. So for polynomial equations, remember that they have the same number of solutions as their degree. All right, so that's important right there. Same number as their degree. Now, it might be that you have multiplicities, so you could have, maybe there's only three distinct solutions, but one of them is a double root for that. But you would have the same number of solutions as you have degree. So if you have an x to the fourth in the problem, that means there's 4 solutions to that equation. So the first thing we're going to try on all of these is we're just going to try to graph them. And that is going to be the easiest if it works, but it does not work for every problem that we will see. We also can solve these by factoring. That is an option. If factoring does not work, we can use quadratic formula. This says or complete the square, but I have not taught you how to complete the square. You might have done it in math too, but we are not going to spend time on that unless we maybe have to at circles. And we'll cross that bridge whenever we get there. And for higher degree polynomials, you can use graphing, and this is synthetic division. I did not do synthetic division, although I think Paloma kind of figured that out. We did long division for that. And that would be like the most complicated one that we'll run into. So let's look at our next slide here. All right, so graphing works great as long as the solutions that show up on your graph are real solutions. Any imaginary solutions will not be visible. So, for example, if I have a graph that looks like this, I can only see one real solution. However, if I only have one real solution, that would make it a first degree. First degree is linear. Does that look like a line to you? No. So this probably has some imaginary solutions somewhere else, and you'd have to know a little more about the equation to know for sure what that is. But we can only see the real solutions. As long as our solutions are real, it's a super easy way to solve the problem. If we have an equation like this, 3x cubed minus 12x squared equals 6 minus 15x. Okay? And we want to solve by graphing. What we are going to do is we're going to move all of the terms to one side so that the equation is equal to 0. So remember that when you move something to the other side of the equation, what do you have to do to the sign? We got to change it, right? So it's going to be 3x cubed minus 12x squared. I like to keep this in descending order, so I'm going to put my positive 15x minus 6 equals 0. Because all we did there is we were just like subtracting 6 over the other side, adding 15x over to the other side. Okay. Now, when I do this, I do want to think about the number of solutions that I have. Because if I've got something to the third degree, oops, I didn't mean to do that. Let's make that a little bit smaller. If I've got something to the third degree, how many solutions do I have? 3 solutions. So you don't necessarily have to write that down every time, but it is a good idea to make yourself a note of that, because sometimes you may only see a few of them on the graph and you're going to have to do something different. Okay? So if we pull up Desmos to look at this, here, if I graph, I'm doing, you want to do y equals 3x to the third minus 12x to the second plus 15x minus 6. Don't put the equals 0 over at the end for this because we just want to graph this as a function, not with the equals 0 on that. If you put equals 0, there, it's not going to graph it. It can't do that. If you do it without the y and put equals 0, it will graph these like vertical lines, which can be used, but I like to do it this way better. So we're looking for when this will equal 0, which is the zeros of the function. It's the x-intercepts of the function, right? So I only see 2 of those here. I see one at x equals 1 right here, and x equals 2, and it tells me I'm supposed to have 3 solutions. Is that 3 solutions? It is not 3 distinct solutions, but I can't have 2 real solutions and 1 imaginary, right? Because we talked about with imaginary, you have to have an even number of imaginary. So, since I know I have 2 real, the third one also has to be real because I can't have an odd number of imaginary. So, what that means is one of these is a double root. Which one of these would be a double root? Double roots happen. Oh, it's not how that open. Double roots happen when you just barely touch the x-axis and go back down. So 1 is the double root here. Or you could say multiplicity. Two. X equals 2, that's just a single. Right there. Okay, does that make sense? Okay, I want you guys to try the next couple on your own. Find all of the real solutions that you can find for these next 2. Alright, so let's look at some other ways of solving. Now, I am going to admit that this particular problem can be solved by graphing. You can just graph this one. However, I did not want to start off with a really, really difficult factoring problem at the beginning. So it can be solved by graphing. Certainly, you can go ahead and graph if you would rather on that. But I wanted us to start off with a little bit of an easier factoring problem. So if we are going to factor, we are going to move all terms to one side so that the equation is equal to 0. I don't actually have to do that here because it's already equal to 0. Then I will factor out the greatest common factor if there is one. So Sawyer, what is our greatest common factor for that? A 4. Can I take any x's out? 1. Good. So I will have 4x times, and then I will have just x squared plus x minus 6 equals 0. Now, after we have factored out a GCF, if there is one, then we want to try to factor what's left. So if I'm trying to factor this, let's see, Peyton, I know I've got x squared, so that's going to be an x and an x. I need numbers I can multiply to get negative 6. What could I multiply to get negative 6? Negative 3 positive 2.
Negative 6 times 1.
Negative 6 times 1.
Negative 1 times 6.
Negative 1 times 6.
Negative 2 times 3.
Negative 2 times 3. Which one of those would give us this positive 1x in the middle?
The negative 1. No. The negative 2 times positive.
Negative 2 times positive 3. Negative 2 plus 3 would give us positive 1. So we can do a minus 2 and a positive 3. Okay? So once we have factored, what do we do then? We're going to set each one of these equal to 0 and solve, or just think about what makes these 0, right? So what would make 4x equal to 0? 0, right? Just divide both sides by 4. X equals 0. What would make x minus 2 equal to 0? 2. We'll just add that 2. So x would equal 2. And what would make x plus 3 equal to 0? Negative 3. So that would be how we would do this if we needed to factor. Now, you could solve this one by, just by graphing as well. Okay, questions there? But we wanted to start with an easier one so that when we got to the next type that we could do this one, even though I want to say that yesterday as I was doing this that it's not what I want it to be. So hold on just a second. Let me graph. Let's graph this one, and I might have to change the problem. All right, if I want to graph this one, it's going to be y equals 9x to the third plus 3x to the fourth minus 27x to the second. No, we're okay here. All right, so if I graph this one, if I graph it, I got 0 as an x-intercept. I'm also getting these other two where I got these like wild decimals, right? It's okay as long as the problem will let you put decimals in. It is okay to get decimals like that. These are still real zeros. I'm supposed to have 4 solutions. Is that 4 solutions? That 0 is double, right? So it is 4 solutions. There's only 3 distinct solutions, so it's only 3 different numbers, but that 0 is double. So these are my solutions. There's no imaginary here. However, sometimes they want us to give our answers as an exact answer. And what they mean by that is that you cannot put the decimal approximation. So you can't give that decimal. You've got to give it, it usually ends up being a quadratic formula problem, and you got to give your answer like 2 plus or minus square root of 7 over 15, or whatever it is. So let's look at how we would do this one here. We would move this over here. I would also write these in descending order, so I'd put the 3x to the 4th first. Then I'll have minus 27x squared. No, I will not. Why would I put that next? Okay, hold on. Let's try this again. We got 3x to the 4th plus 9x to the 3rd, and the minus 27x squared will go last. So having your exponents in descending order is going to make it easier to factor. Okay, once I get everything to one side, I've got to look for a greatest common factor. Let's see, Silas, what could I factor out for this one? 3. Can I take any x's? What's the lowest number of x's you have? 2. So we can take 2 of them. We'll do x squared for this. So we'll have a 3x squared out front, and then we will have x squared plus 3x minus 9 equals 0. And so we're trying to factor this middle part, but to get negative 9, I could do negative 1 and 9, I could do positive 1, negative 9, and I could do 3 and negative 3. Those are my only 3 options to get negative 9, right? Do any of those give you a positive 3 in the middle? They do not. So if you find yourself trying to factor, or particularly if you see those, if you graph it and see those weird decimals, this one does not factor. So what you're going to do is you're going to set each one of your factors equal to 0. So 3x squared will equal 0, and we're going to say x squared plus 3x minus 9. We're looking for where that equals 0. And over here, you could just divide both sides by 3. You're going to get x squared equals 0. You could square root both sides. X is going to be 0. You could put the plus or minus there, but do you need a plus or minus with 0? No, because 0 is neither positive nor negative, so you don't need that, right? For this, you can't factor it, so you're going to have to use quadratic formula. So you would have x equals opposite of b, so negative 3, plus or minus the square root 3 squared minus 4 times a, which is 1, times c, which is negative 9, all over 2 times a, which is 1. We don't want to type this into Desmos and get a decimal because we want to have it as an exact answer. So what we're going to do is we'll do negative 3 plus or minus, and we can take Desmos over here and just, or your calculator, either one. Just put the stuff under the square root, the 3 squared minus 4 times 1 times negative 9. We're going to get 45. All over 2. So x equals 0 is one of our answers. You're probably going to see square root of 45 broken down. What could you break 45 into? 9 and 5. And what's the square root of 9? 3. 5 we cannot take the square root of, so we'd leave it underneath. So it would look like this, negative 3 plus or minus 3 square root of 5 over 2. So there are your other 2 there. And if we do type these into Desmos, like if we want to check to make sure we've done it right, if I type in negative 3 plus square root of 45 all divided by 2, I get 1.854, and over here on my graph, that was 1.854, right? And if I were to do that same thing, but with the minus instead, I'd get negative 4.854, and over here on my graph, that's the same thing there. Okay. Are these real or imaginary here? These 2 roots. They are real. So they show up on the graph. They do not have negatives under the square root. Now, if I had like a negative 5i right there, or a negative 5 under the square root, negative 45 right here on the square root, then that would make them imaginary. Okay, here. We just got a couple more things to do. Alright, so, actually this might be, is this the last one? on there? Is this the last one on? Yeah. Okay. So, all right, here's the grand finale of all things difficult that you may have to do for this. A lot of these you are going to be able to do with the graph. Some of them you can do a lot of it with the graph, but you might need to get your exact answer using that quadratic formula. And then we're going to have ones that look like this. And this is a long question. So if I graph this on Desmos, because that's kind of where I want to start every time, because maybe I can just do this by hand. Let's see if I can do this so I can still have plenty of room here. Okay. All right, so I need to all right. I need to move everything to one side. I generally like to keep my highest exponent positive. So even though I got to move more stuff, I'm going to make this x to the fourth minus 5x cubed minus 10x squared minus 20x minus 56. So if I type that in over here on Desmos, I got x to the fourth minus 5x to the third minus 10x to the second minus 20x minus 56. Now, if I look at my graph here, I do have a couple of real zeros. Okay, so I do have some real zeros right here. But it looks like I've only got 2. Doesn't look like I've got any others. And how many solutions am I supposed to have for this? 4. I'm supposed to have 4. So, let's pay attention to what we've got as our solutions. I've got x equals -2. So, x equals -2, and I've got x equals 7. Those are 2 of my solutions. The good news for this is, like, if you have one of these problems, you can get a couple of the answers right just by graphing, and then maybe you might struggle getting the others, but it might get you some partial credit on the question, even if you just get the real ones on my test. On the actual exam, final exam, they don't do any partial credit on that one. So, I've got these 2, but I'm not going to be able to get the other ones using the graph because I can't see them. So, let's...
Did Ms. Belt say anything about checking?
She said that you do not have to make it up. So I'm not going to make you. Unless you're just dying to take it and want me to find. Okay. She said that you do not have to make it up because it is not a requirement that we test students that that miss it. I might not should have said that out loud. Everybody might skip the next one. So x equals 2, x equals -7. Now, if x equals 2 is a solution, what's one of the factors? Like if we think about what we were doing in the last section. If I'm like factoring this out, what's one of the factors? X minus 2, right? Opposite sign. So like if I'm thinking, because really what I want is I want to have this factored out. So I want to have like f of x equals and then have it all kind of factored out here for that. So x minus 2 is going to be a factor if x equals 2 is a solution. So here's what we've got to do for these. We got to bring out that long division here, and we're going to use x minus 2. Did I skip one? Oh. Is this one on there at all?
It's on there. It's just points.
Oh, I messed this up a little bit but I had already copied those. So I had them numbered wrong, and I didn't have the title above it. So I had already copied those, and I didn't go back and change it. But it's same question here. So yes. Oh, let's fix that. Okay, so that means actually we need x plus 2. Thank you for that. So if we're going to do long division here, and this will be like, this is our last section of this unit, last problem on the notes. This is not something you got to be able to do all the time, but this would be like the most difficult type of problem you would run into. So what times x would give us x to the 4th? No 4. If I'm trying to get x to the 4th, I need an x to the 3rd. Yes. Because x to the 3rd times x to the 1st gives me x to the 4th. I also have to do x to the 3rd times 2. So I'll get 2x to the 3rd. Alright. Then I must subtract. Alright, and when I subtract, it will cancel these two right here out. I will have negative 5/3, or negative 5x to the 3rd minus 2x to the 3rd. It will give me negative 7x to the 3rd. And I will bring down a negative 10x squared. You are subtracting, so you got to do negative 7 minus 2. To get that negative 7. Because it was a plus, but then we have to subtract. Right? Let's do the next step, and I'll try it. Getting signs mixed up is one of the hardest things. So we're asking what times x would give us negative 7x squared, or x cubed. The answer is negative 7x squared. So we would do negative 7x squared. All right, we multiply negative 7x squared times our x plus 2 right here. Negative 7x squared times x gives us negative 7x to the 3rd. Negative 7x squared times 2 gives us negative 14x squared. I have not subtracted yet. Okay? That was just the multiplying. So what I've got to do now is I've got to subtract. So when I subtract here, I'm doing negative 7x cubed minus negative 7x cubed, which makes that positive. A negative 7 and a positive 7 cancels each other out. Okay. Same thing is going to happen over here. I have not subtracted yet. So I got negative 10x squared minus negative 14x squared. And where I have a minus a negative, that becomes like I'm actually adding. And so when I do this, negative 10 plus 14 is going to give me a positive 4x squared. Okay, here. Why do you keep the x squared? You are adding and subtracting, so you're just combining your like terms. You don't take that away. If you were dividing there, you would, but we're just adding and subtracting. So it's like having like a 3x plus a 2x and getting a 5x. You don't change the exponents. Okay. So what times x will give us 4x squared? 4x. So we got a plus 4x here. 4x times x is 4x squared. 4x times 2 is plus 8x. We have not subtracted yet. We must subtract. So we're subtracting here. 4 minus 4 is 0. That goes away. Here we're doing negative 20x minus 28. Or minus 8 gives us 28. So these are going to be negative 28x. We've got to bring down. Okay. And then we got to say what times x would give us negative 28x. That is a negative 28. So negative 28 times x is negative, it's not letting me write down here at the bottom, negative 28x. And then negative 28 times 2 is negative 56. So those both cancel whenever we subtract. So what we have essentially now is we have our result, which is x to the third minus 7x plus 4x minus 28. But we're not done yet because we could divide again for this. Because we have this other 0 right here. We've got x equals positive 7. So that means x minus 7 is also a factor. You don't want to use this x to the fourth anymore. You want to use the answer from this first problem that you did. So when we divide now, we're going to do x minus 7, and we're going to use the x to the third minus 7x. That should be squared right there, plus 4x minus 28. Okay. Alright, so what times x would give us x to the third? That is x squared. I'm going to run through this a little faster just because we need to get going. If I'm losing you, take my word, there won't be that many of these on there. Or come to tutoring. So if I do x squared times 7x, I get 7x squared. Now I'm going to subtract. Let me use my different color so it... my different color, I'm subtracting here, that goes away. I'm subtracting here, which becomes like a positive. This also goes away this time. So, I'm just going to have to bring down the next stuff because I can't really bring down anything here. I got 4x minus 28. I'll bring those down. What times x would give me 4x? 4. So I got plus 4. 4 times x is 4x. 4 times negative 7 is negative 28. When I subtract those, it will cancel them both. So essentially what has happened here is I have factored this into x minus 2 times x minus, hold on, that was a plus right there, wasn't it? X plus 2 times x minus 7 times x squared plus 4. So we already have our solution of x equals negative 2. That came from this one. We already have our solution of x equals 7. That would come from this one. All we've got to do for this last part is we've got to set x squared plus 4 equal to 0. To solve that, we need to subtract that 4. Let's go up here in another room. X squared is going to equal negative 4. How do I get rid of a square? We will square root both sides. So x will equal plus or minus square root of 4 is 2, but we got a negative under there, so it's got to have an I. So we got x equals plus or minus 2i, which is actually two solutions. It's a positive 2i and a negative 2i. So there are my 4 solutions for this. Okay. You will not run into a lot of these. You might see one whenever it comes test time. I think the worksheet has 2 on it that have to be done this way. Okay, questions?